So now we're going to use the half angle formulas to find exact values. So on all these, the angle I give you is going to be half of an angle that we know. Hopefully we know. So 22.5 is half of 45. So this is really the same thing as saying the sine of 45 divided by 2. Basically multiply 22.5 by 2 to figure out your angle. 45 is going to be the x angle in this when I apply the identity. So the identity is plus or minus, and we're going to figure that out in just a sec, whether it's plus or minus. It can't be both. Square root of 1 minus the cosine of x, which is 45 degrees. Make that look better. All over 2. Now, is it positive or negative? This is based off of the actual original problem. 22.5 is in quadrant 1. Everybody's positive in quadrant 1, so this is going to be positive. I don't really need the plus sign there, but just so you know. I'm not going to say plus or minus in the end. It's one or the other. So now everything from here on out, well, after I do this, the cosine of 45 is root 2 over 2. Now everything from here on out is algebra. This is all inside of a square root. So there's a few ways you can attack this. You can combine the numerator into a single fraction first if you want. One is 2 over 2. So you'd have 2 minus root 2 over 2. And that's still all over this number 2. Lots of 2's flying around here. If I multiply by the reciprocal, that's multiplying by a half. So I'm taking that 2, I'm flipping it up and multiplying by a half. So now it's all over 4. And I can go one step further. And I can actually take the square root of 4. The square root of 4 is 2. But on top, I can't do anything. So I just got 2 minus root 2 inside of a square root. That's a very funky looking answer. We're not used to seeing square roots inside of square roots, but that is a precise, exact answer to this. The algebra part of this, basically from here over, is where students will get tripped up on these. For letter B, tangent of 67.5. Okay, so 67.5 is half of some angle that we know. To figure that out, multiply it by 2, and you get 135. Oops. I think I'm a little too close to that. Let's move this over a fuzz. So this is tangent of 135 over 2. Now, again, for tangent, you do not have to have it memorized. And if you look at your identity sheet, there are actually 2 versions of it. I'm going to use, it doesn't matter which version you use, I'm going to use the 1 minus cosine of the x angle. Remember, the x angle would be the 135. That's a 1. Over the sine of 135. Now notice on the tangent, there's no like, oh, is it plus or minus? The correct signage on it, positive or negative, will come out of the problem. So the cosine of 135, well, that's a 45 degree in the second quadrant. Remember, cosine is negative in that quadrant, so it's actually 1 minus negative root 2 over 2. The sine in the second quadrant is positive, and it's also root 2 over 2. So I've got 1 plus root 2 over 2 all over root 2 over 2. Now, again, there's options on how you want this. On the previous one, I combined the numerators first. This one I'm gonna do a different way just so you can see both ways work. I'm gonna do the whole split it into two. So I'm gonna write 1 over root 2 over 2 plus, oh, this is convenient, root 2 over 2 over root 2 over 2 is 1. So I just need to clean up this red part now. If I flip that, because it's 1 over, I'd have 2 over root 2 plus 1. 2 over root 2, just off to the side here. 2 over root 2, if I multiply top and bottom by root 2 to rationalize it, I'd have 2 root 2 all over 2. 2's cancel. And so I'm left with a final answer of root 2 plus 1. There's the exact value of the tangent of 67.5 degrees. For letters C and D, these are in radians. So you have two choices. You can convert them to degrees or leave them in radians, whatever you want to do. On the first one, I'm going to leave it in radians just so we can see how that works. 11 pi over 12 is half of some angle. Remember what we did up top? We took the angle and we multiplied it by 2 to figure out what the x angle would be. Well, that would be 11 pi over 6. So my x angle is 11 pi over 6. So now I'm going to apply the identity for cosine half angle. Cosine's half angle is 1 plus cosine of the x angle, which is 11 pi over 6. Now all over 2. Now remember, I've got to figure out, is it positive or negative? This is where you've got to think, where would 11 pi over 12 land? 11 pi over 12 is more than half, more than a pi over 2, but less than pi. It would be over here. Cosine is negative in the second quadrant. So this one's going to be negative actually on this. So that's how I determined whether it was positive or negative. Okay, the cosine of 11 pi over 12 is negative, I'm sorry, 11 pi over 6, excuse me, is positive root 3 over 2. Because 11 pi over 6 would be right here on the unit circle. Cosine's positive in this quadrant. The adjacent is root 3 over 2. Okay, so that's it for the trig part of this. Now comes the algebra. And again, you've got options on how you want to do this. If I decided to combine these into a single fraction, that'd be 2 over 2. So that's going to be, let's see, 2 plus root 3 all over 2. And that's still all over this 2 down here. Multiply by the reciprocal. So now I have negative root 2 plus root 3 all over 4. And just like I did a couple problems ago, I can take the square root of 4 to get 2. But on the numerator, I could just put it in the square root, but I can't do anything with it. So negative square root of 2 plus square root 3 all over 2. Again, very funky answers, but there's definitely a pattern to them. For letter D, Again, you can leave it in radians or you can convert it to degrees. So you could, if you're more comfortable with the degrees on this kind of stuff, you multiply it by 180 over pi. You can convert this over to degrees. It's 75 degrees. So let's do that this time. So this is really the tangent of 75. And again, 75 is half of an angle that we know is half of 150. So the 150 is my x angle. And again, I apply either one of the tangent identities. There's two of them for the half angle. I'm gonna use the same one I did on the other problem. It'd be 1 minus the cosine of 150 over the sine of 150. And again, I don't have to worry about a plus or minus. The correct signage will fall out of this when I do the tangent. Okay, so let's see what we've got. 1 minus the cosine at 150. Well, 150 is here. That's a root 3 over 2, but it's negative. So it'd be 1 minus negative root 3 over 2. That's going to turn into plus. The sine of 150 is a half. And so I end up with 1 plus root 3 over 2 all over a half. And again, a couple ways you can deal with this. Let's say I decided to add these fractions. Just like on the previous problem, that's going to give me 2 plus root 3 all over 2. And then I'm dividing by a half, which means I'm multiplying by 2 over 1. Well, that's convenient. 2's cancel, and I'm just left with 2, try that again, 2 plus root 3. And there's my answer. For number 5, this is one of these, again, where we've got the expanded out version, and we're going to try to condense it using the identities. 1 minus cosine all over sine, that we just did on the previous problem, that's tangent's half angle identity. Now, be careful here. The x angle is 4 theta on this. So that's what goes over 2. And so then I can say, oh, that's tangent of 2 theta. So that was one of those just crunching it down, trying to recognize the expanded out version. For number 6, we've got to do some calculation. Notice again, we're told a trig function. And that means we're going to have to draw a triangle again. We're told that the x angle is between 0 and 90. Now that means that if my angle is between 0 and 90, dividing the angle by 2 is still between 0 and 90. Technically between 0 and 45. Basically, though, what I'm saying is these x over 2 angles are all in the first quadrant. So everybody's going to be positive. So when you have that, according to the identity, a plus or minus, we don't need the minus. It's definitely going to be positive. So we know all these are going to end up positive. Again, whenever I'm told the value of a trig function, it's probably a good idea to draw it. So sine opposite over hypotenuse. We've had this same triangle several times. Pythagorean theorem tells me that the adjacent is 12. So now first thing I'm gonna do is sine of x over 2. Again, we know it's the positive of the square root, so it's square root of 1 minus the cosine of x all over 2. Remember, this 5/13 was for the angle x, not for the angle x over 2. So the cosine of x is 12 over 13. So this would be inside of the square root, 1 minus 12 over 13 all over 2. And again, multiple ways you can simplify this down. If you combine the numerators, or combine it into a single fraction, I guess, you'd have 13/13 minus 12/13. So that's going to be 1/13 all over 2. Multiplying by the reciprocal, you'd have square root of 1 over 26. Let's make that 1 look a little better. You could take the square root of 1, but you really can't take the square root of 26 nicely. And no need to rationalize it. We'll leave it like that. So there was the sine of x over 2. Cosine, almost an identical half-angle formula, except that it's 1 plus cosine x all over 2. So it's going to follow very similar, except that it's 1 plus 12/13 all over 2. Well, that's going to give me 25 over 13 all over 2. If I multiply by the reciprocal of 2, I've got the square root of 25 over 26, which I can take the square root of 25 to get 5, but then the square root of 26 I can't do anything with. So there's the cosine of the half angle, x over 2. For tangent, remember, you can use the formula, but I've already figured out the sine, the sine of x over 2 and the cosine of x over 2. So the tangent is just the sine over the cosine. So that would be 1 over root 26. If I'm dividing by that, I'm multiplying by root 26 over 5. Root 26 is canceled. The tangent must be 1/5.